Welcome back again. We are on lesson 4. Just a reminder, make sure that you are checking your homework, posting the answer keys up on the module. And if you do have any questions, definitely reach out, ask me. Again, I'm trying my best to make comments on your assignments that you're handing in. Today's lesson, we're not learning anything new. It's just going to be word problems. So you should be okay with it. It's solving for sides and angles. We'll just go through a couple of questions. This is not going to be as long of a video. I might skip around a bit. Just take a look at this first one here. It's telling us that we have a ladder and it's going to be unstable. The ladder will be unstable, meaning it might fall or whatnot if it makes an angle with the ground that is greater than 60 degrees. So we have a 12-foot ladder. We want to know if the ladder will be unstable if it reaches up to the window at 10 feet. Okay, so we need to solve for the angle, pretty much. And now it's the angle that is made with the ground. So the angle that's made with the ground, that's going to be right here. So we want to solve for this angle. So I'll make that an X. Okay, let's label our sides. Opposite, adjacent, and hypotenuse. We're solving for an angle. Whenever you solve for an angle, anytime you solve for an angle, it's always inverse trig. We're dealing with opposite and hypotenuse. Opposite and hypotenuse, that's going to be sine. So remember our SOHCAHTOA. Sine of some angle, we don't know it, is equal to opposite over hypotenuse. We're solving for the angle. That means we're going to be using inverse trig. X equals sine inverse of 10/12. We'll go ahead to our calculator and we'll type second sine of 10/12. So it's coming up with the angle that gives us a ratio of 10/12. And that would be 56.44. And then we could say, all right, well, it's not going to be unstable because it is not greater than 60. So it is not unstable. Okay, let's look at this next one. To determine the height of a tree, loggers will measure the angle of elevation to the top of the tree. Remember, angle of elevation is somebody's eyes looking up at an object. So right here is our angle of elevation. And they're telling us if a logger's eyes are 5 feet 3 inches above the ground and the angle of elevation to the top of the tree is 38 degrees, when standing 25 feet from the base, determine the height of the tree. Okay, determine the height of the tree. Okay, that means we want to find this we want the whole height. So this whole thing we want to find. All right, we have a couple of problems here. The first problem is if we're using right triangle trigonometry, if we're using a right triangle here, here is our triangle, we could only find this height. So from the right angle up to here, we're going to find that. So maybe I'll call that X. To find the whole tree, well, we'll find that, and then we'll have to add on this 5 feet 3 inches. So that's one problem. Easy enough, we'll tack on that extra 5 feet 3 inches. The other problem is we have different units. I see feet and I see inches. So we have two different units. We need to convert it and keep it and make it the same. So we want to convert either over to completely to feet, or we want to convert over completely to inches. The best course to take here is to convert everything over to inches because that's what we want the end answer to be. So let's we'll go ahead and do that. So hopefully you know that 1 foot equals 12 inches. That's our kind of conversion here. So we could do 5 times 12, that's 60. So 5 feet equals 60 inches. All that I'm doing is I'm multiplying 5 by 12. So that means this person's height is going to instead, we'll make it 63 inches. Okay. We also want to figure out, convert that over. So I'm just going to go to the calculator. 25 feet, well, there's 12 inches in a foot, so 25 times 12 would be 300. So I'm going to change this over to 300 inches. Okay. Now we'll go ahead and label our triangle once again. This is our opposite, this is our adjacent. So if from here to here is 300 feet, then from the person's eyes to the tree is 300 inches, I should say. We're dealing with O and A, that's tangent. So tan of some angle equals opposite over adjacent. Let's substitute in what we have. We have the angle is 38. The opposite we don't know, we'll call that x, and the adjacent is 300 inches. Put this over 1 and cross multiply. So x equals 300 times the tan of 38 degrees. Go over to the calculator. Could just type that straight in. 300 times tan of 38. And we get 234. I'll just kind of add that in over here. So 234.38. We want to go ahead and do this to the nearest inch. So now remember, from here to here was 234. So from here to here was 234. We need to add on that additional 63. So this I'm going to tack on plus 63. I'll add that up. Oh, COVID-19 update. Okay, so add 63. So then to the nearest inch, it's going to be 297 inches. So a couple of things going on. We had to convert, we had to tack on at the very end, but our final answer is 297. Question 3, we have an isosceles triangle. Let's go ahead and draw that out. Draw our own isosceles triangle here. It has legs of length 14. Remember, the legs are the congruent sides. So we have legs of 14 and a base with a length of 10. What is the measure of its vertex angle to the nearest degree? This is an isosceles triangle. It doesn't say it's an isosceles right triangle, it's just an isosceles triangle. We need to make a right triangle out of this. What we're going to do is draw in our own altitude. So by drawing in our own altitude, that's creating a right triangle. It's creating two congruent right triangles. So a couple of lessons ago, we talked about an isosceles triangle. If it's an isosceles triangle, the altitude is important because it's also the median, it's also an angle bisector, it's also a perpendicular bisector, so it's kind of all of them. So what this could do is, all right, well, now instead of calling that whole thing 10, I can call this 5 and this 5. We want to find the measure of the vertex angle. So we want this entire thing right here. Since this is also an angle bisector, what we can do is just isolate one of these triangles, find this angle, and then the one right next to it, I'll do it in a different color here, this one right next to it is going to be congruent. They're going to be the same, so we could just double it. Okay, so let's maybe draw out kind of half of that triangle. Okay, we have a right angle here. So then this is 5, this is 14. We're going to solve for this angle up here, x. Let's label this. Okay, across from the right angle, that's our hypotenuse. This is our opposite. So it's looking like sine. Sine of the angle, which we don't know, is equal to the opposite, which is 5, over the hypotenuse, which is 14. We're solving for an angle. Anytime we solve for an angle, it's always inverse. Make sure you're showing this step right here. We want to do sine inverse of 5/14. Now we can go to our calculator. Second sine 5/14. Hit enter. Now remember, that was only half of it. We need to double it because that altitude acts as an angle bisector. And we get 41.8. So x equals 41.8. This half up here was about 21. This half over here was again about 21. We want to round to the nearest degree. So 42 degrees. So moving along, we'll look at exercise 4. They give us a diagram. They tell us that a lighthouse is 200 feet above sea level. So the lighthouse is 200 feet above sea level. So we can go ahead and label this as 200. It spots a boat. So the lighthouse, someone up at the lighthouse spots a boat at an angle of depression of 28 degrees. So this is looking down at the boat. Now just remember that this line, let's do that again. So this line and this line down here are parallel. So we have a transversal going through, which means we have alternate interior angles, so that this would also be 28 degrees. What is the horizontal distance to the base of the lighthouse, round to the nearest foot? So I'm going to give you a moment, pause the video, and try this one on your own. Here is the correct work with the correct answer of 376. We're dealing with tangent. We have an opposite adjacent. Cross multiply, and then solve it out. We'll divide both sides by tan of 28. So I think we're going to stop here. You do not need to do the rest of these questions on the classwork packet. If you want to do them, that's totally fine. The only thing I need submitted is the homework. So other than that, I hope you have a great rest of your day. All right, bye.